In example 2, our quadratic function is f of x equals x squared plus 2x plus 1. So we're going to go through the same process we just went through for example 1. Okay, let's first find the vertex of this parabola. Okay, so we need to identify our a and b. Okay, so our a value here is 1. The number in front of x is 2, so that's our b. And then we'll go ahead and identify our c in case we need it. That's the constant, so that's going to be 1. Okay. The number in front of x squared, the a value, is positive, so that means that this parabola is going to open upwards. Okay, so make sure when you get to the graph that you do have an upward opening parabola. All right, so to find the vertex, remember it's going to be an ordered pair. We're going to get the x-coordinate by applying the formula negative b over 2a. Okay, so this is going to be negative 2 over 2 times 1. Okay, so we're going to get negative 2 over 2. So the x-coordinate is going to be negative 1. And to get the y-coordinate now, we need to plug this x value into the original function. Okay, so our y value, here's y, is going to be negative 1 squared plus 2 times negative 1 plus 1. Okay, and if we simplify, this is going to be negative 1 times negative 1, that's positive 1, minus 2 plus 1. So that's going to be from left to right, that's negative 1 plus 1. You're going to get 0. Okay, so the vertex is going to be at the point negative 1, 0. Okay, now moving on for the x-intercepts. Okay, again, to get the x-intercepts, you need to set y equal to 0. Okay, so we're going to get 0 equals x squared plus 2x plus 1. Okay, so again, your options here for a quadratic equation are to factor or to use the quadratic formula, whichever you prefer. Okay, again, this one is not too bad to factor. Okay, one side has to be 0, either to factor or to use the quadratic formula. Don't forget that. Okay. Again, if you choose to factor and you're not the greatest at it, remember, you can get away with trial and error in this class. The factoring won't be too complicated. Okay, if not, use the quadratic formula. Okay, all right, so if you play around with this one, x squared breaks down into x times x. 1 breaks down into 1 and 1. Okay, and both of the signs are going to be positive. Okay, again, you need to always check yourself to make sure whatever you think the factorization is actually works. Foil it back out, okay, to make sure you get what you started with. This is going to be x squared, and then x times 1 is 1x, and then the insides here is going to be another 1x, so that's going to combine to give you the 2x, and then 1 times 1 is positive 1. Okay, so this works. Okay. All right, so we need to take each factor and set it equal to 0. Notice here that the factors are identical. Okay, so you only need to set it equal to 0 one time. Okay, and solve. You get x equals negative 1 is your x-intercept. Okay, so as an ordered pair, okay, you're going to get x equals negative 1, y is 0. Okay, and this is a bit interesting because this x-intercept is the same as the vertex. Okay, so we'll see what happens. All right, now on to the y-intercept. So we're going to set x equal to 0. Okay, so go back to your original equation, set x equal to 0. So we're going to get y equals 0 squared plus 2 times 0 plus 1. Okay, this is going to simplify to be 1. Okay, so your y-intercept is going to be the ordered pair x equals 0, y equals 1. Okay, and again, we will put the graph together and then we'll come back to write down the axis of symmetry. Okay. All right, so let's go to our graph. We know the vertex and the intercepts, so we're going to go ahead and plot those points. Okay, so we have the vertex, which is the same as the x-intercept. It's going to be at negative 1, 0. And we have a y-intercept at 0, 1. And that's all we know. Okay, but we talked about in the last example, you need at least 3 points to determine a parabola, and we only have 2 here. Okay. So you might think, well, let me go ahead and pick another x value and plug it in. which you can do that, but you're creating a little bit too much work for yourself. Because what you can do, and we didn't do this in the last example, but you can actually apply the axis of symmetry here. It can be helpful for graphing a parabola, okay? Remember, the axis of symmetry is a vertical line through the vertex. So I'm going to go ahead and draw it in, even though I haven't completed the parabola yet, okay? So here is my axis of symmetry, and we know that the parabola has to be symmetric about this vertical line, okay? So that is what's going to help us get our third point, okay? So see this point, okay? This is 0, 1. Since it's on the parabola, and the parabola has to be symmetric about this pink line, okay? We also know that this point, -2, 1, has to be on the parabola, okay? Because if we took our sheet of paper and folded it along the pink line, okay, 0, 1, and -2, 1 would lie on top of each other, okay? So that's our third point, okay? And we know our parabola should open upward, okay? So we can go ahead and fill it in, okay? So we're going to come down, go through the points. The vertex has to be the lowest point on the parabola, and then go back up through 0, 1. And again, put arrows on the end because your parabola goes up forever, okay? And that's what your parabola looks like, okay? All right, let's go back and fill in the equation of the axis of symmetry, okay? Again, we need an equation. It's a vertical line, so it's going to be x equals, okay? And it is going to be x equals the x coordinate of the vertex, okay? The vertex is -1, 0, okay? So it's going to be x equals -1. No work required. All right, let's jump to part B. We've already graphed, so now we just need to fill in the attributes listed, okay? The domain of the parabola is going to be all real numbers, okay? We talked about in the last example, any quadratic function, ax squared plus bx plus c, is a polynomial, so the domain will always be all real numbers, okay? The range, we need to go from the bottom point to the highest point and list the y values, okay? So the lowest point on the graph is the vertex right here. That has a y coordinate of 0, okay? And the highest point is positive infinity. We are going to include the 0 because there's no open circle, okay? All right, increasing, decreasing, constant, or there is no constant, but increasing, decreasing, I will do what I did in the last problem, okay? I will outline it from left to right, or trace the curve, okay? Again, the arrows on the end just indicate that the parabola is going up forever. You should not look at that for increasing or decreasing, okay? All right, so if I go from left to right, I am first falling, okay? So I'm going to be decreasing on this side of the axis of symmetry. So in green is where I'm decreasing. And then once I get to the vertex, I'm doing the opposite. So I start rising or increasing, okay? So on the right side of the vertex or axis, I am increasing, okay? To write down the answer, remember, we have to use x values, okay? So if I write down the decreasing part first, I'm going to cover up the increasing part. So this is occurring over these x values. So from -infinity to -1. Okay, and again, we don't care about endpoints. We're not particular about those for increasing or decreasing. Okay, and then for, oh, I'm sorry, I put that in the wrong spot. Okay, this should be decreasing. Whoops. Okay, so here's where we're decreasing. And then if I look on the right side of the axis, I am rising, so I'm increasing, okay? And that's happening over these x values. So I'm increasing from x equals -1 to positive infinity. Okay, and so that's what should go there. Okay. All right, part C, okay, is that inequality that I'm throwing in from section 4.5. Okay, for what values of x is x squared plus 2x plus 1 greater than 0? Okay, again, notice this is f of x. Okay, it's your original function. Okay, so this question is really asking, where are the y values bigger than 0? okay? So where do you have positive y values, okay? And we know that we have positive y values when we are above the x-axis, okay? So we want to be above the x-axis here, okay? So at first glance, and I did this with the last problem, I went back and I put everything in yellow, okay? At first glance, it looks like the entire parabola is above the x-axis, okay? Which is almost completely true. Okay, there's one little problem. Okay, so it is entirely above the x-axis except for this one point at the vertex. Okay, at -1, 0, the vertex, your y value is actually equal to 0. Okay, and we can't have that because we need the y values to be strictly greater than 0. Okay, so the parabola is above the x-axis everywhere except at this one point. Okay, so the way we're going to write down the answer is everything, all the x values to the left of the vertex. Okay, so cover that up, all the x values to the left of the vertex. So from -infinity to -1, we can't include -1 because its y coordinate is 0, and we know the y coordinates can't equal 0. Okay, and then our other segment is going to be everything to the right of the vertex. Okay, and those are going to be the x coordinates -1 to infinity. Okay, these x coordinates. Okay, again, we have to throw out this one x value of -1 because its y coordinate is actually equal to 0. Okay, so let's put our union symbol there. Okay, and this is just stating that your y values are bigger than 0. You have positive y values everywhere except right here, okay, where you actually have a y coordinate equal to 0.